Do you guys know what parallel lines are? What? Yeah. Yes, lines that will never touch. Okay, so do you see this line here, AB, and this line right here, CD, are parallel? They'll never touch. Let's calculate their slope. So we're going to use points AB. So do you see I'm going down 1, 2, 3, 4, 5, 6. And then I'm going over 1, 2, 3. So the slope of AB is down 6 over 3, which, what does that reduce to? -2. Okay, so now we are going to measure the slope from C to D. Does everybody see I'm going down 1, 2, 3, 4 over 1, 2? Yes? So the slope of CD is down 4 over 2. What does that reduce to? -2. So what do you notice? They are the same, and that's something you need to know, that slopes of parallel lines have the same slope. Got to remember that. Okay. So let's do example 1 here. Line AB passes through A, which is 3, 6, and B, -1, -2. Line CD passes through 4, 5, and -1, -5. Line EF passes through blah, 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 blah. Are the lines parallel? Graph the lines. So the only way you can prove that they're parallel is by using the slope. If the slopes are the same, then they're parallel, okay? You can't just go by looking at it and say, yeah, they look parallel. Okay, so we're going to plot 3, 6. And we're going to use a ruler. Hopefully everybody has a ruler at this point. -1, -2. And we're going to connect the dots here. I'm going to extend it. There we go. And what am I supposed to do with the line? Arrowheads. Okay, so I'm going to actually label this point here. So this is B and this is A. Yes? Okay, so now I'm going to plot CD. So that's 4, 5. There's my C. And -1, -5. And that's my D. Again, I'm going to take my ruler. A calculator for your ruler, it works. Because all you need is a straight edge, right? Okay. Looks like they're parallel, but we have to justify it by using the slope here. But we're going to do EF first. EF is 3, 1. And F is 6, 6. So that, sorry, is E and F. Connect the dots. Okay. Okay. I'm going to give you a second to calculate the slopes for each one here. So slope of AB, slope of CD, and slope of EF, and then we'll discuss. Okay. Okay, so I'm going to calculate from B to A. So this is up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. I got 2. C to D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4, 5. You don't have to pick actually CD. You can pick any point on there. EF. EF. So 1, 2, 3, 4, 5 over 1, 2, 3. Is that what you got? So what could I conclude here? Yes. Therefore, have you seen that symbol before? Therefore? Oh, good. Where'd you see it before? I did. Okay, there you go. I don't even know what A, B. Does anybody know the parallel symbol? Yeah, they are. Parallel to CD. Since both slopes are 2. Okay? So if I ask you to prove that 2 lines are parallel, you have to show the 2 slopes are the same. Everybody got it? All right. Moving on. Lines PQ and RS, they intersect at a 90-degree angle. What is that called? Perpendicular. It makes a right angle, but the lines are perpendicular. Perpendicular. Let's calculate the slopes. So M of PQ and M of RS. Okay. From P to Q. Actually, we're going to have to do from Q to P. So we're going up 1, 2, 3, 4, 5, 6 over 1, 2, 3. Yes? So that was PQ. So up 6 over 3, that reduces to 2. Yes? Now we're going to do RS. So we're going to go from R to S. We're going to go down. Does everybody see we're going down? 1, 2 over 1, 2, 3, 4. So we're going down 2 minus 2 over 4. What does that reduce to? Negative 1/2. What do you notice about the slopes? They're not the same. Anybody know what that is? What do you mean by opposite? So just so you know, opposite in math actually means opposite signs. So that's why I was trying to clarify, because they are actually opposite signs. But 2, does everybody see 2 over 1? What happens when I change it to 1 over 2? What is that called? Nope. Nope. Sorry, maybe you don't even know this term yet. Huh? Yeah, you should know from because you divide fractions, multiply reciprocal. Reciprocal, yes. When you change the numerator and the denominator to the denominator and the numerator, that's called reciprocals. So they are opposite signs and reciprocals of each other. So there's 2 things going on. They're reciprocals and they have to have the opposite sign. So sometimes they try to trick you on a multiple choice and they'll give you that the slope is 2 and the other slope is 1/2. They're reciprocals, but they're not the opposite signs, right? So another way you can look at this is that if I were to multiply 2 over 1 times negative 1 over 2, what do I get as the product? What do I get when I multiply these 2 together? You see the 2's would cancel and I get negative 1. I don't know if I'd ever use that, but it's something on trivia you might need to know sometime in your lifetime. I would just remember they're opposite signs and reciprocals. Sometimes they're referred to as what's called negative reciprocals of each other. So this term, negative reciprocals, mean you're switching the sign and you're reciprocating, right? Yeah? So they have it in this box here. Slopes of oblique. What does oblique mean? Yeah, they have some kind of slope to it. It's not vertical or horizontal. Slopes of 2 oblique perpendicular lines are negative reciprocals. That is, the line with a slope m is perpendicular to a line with a slope negative 1 over m. So just to clarify, if my slope is 4 over 5, what would the perpendicular slope be? Anybody? Gavin? Yep. Okay, just to clarify again, if this was negative 4 over 3, what would my perpendicular slope be? Yeah, and it would be positive 3 over 4. Okay, so did everybody understand that? Okay, so now we're going to do example 2. And we are going to do the same thing again. We're going to draw some lines, and we're going to try to figure out which ones are perpendicular. So we're going to calculate the slopes and then figure out which ones are negative reciprocals of each other, okay? So I'll give you a second to draw this and calculate the slopes, okay? Okay, so I drew all my lines here. Yours look like mine? Yep. Okay, so now I'm going to do the slope of PQ. Okay, so that is up 1, 2, 3, 4 over 1. Yes? Did you get 4? Yep. Okay, perfect. Now we're going to do the slope of RS. So that's from R to S. So I'm going to do it from S to R because I do left to right. So I'm going down 1. Sorry, I can't read it this way. Down 1, 2, 3, 4 over 1. So negative 4 over 1, which is negative 4. Are those perpendicular? No. Is that what you got? Okay, just checking. And then TU. So I'm going from T to U. So I'm going up 1 over 1, 2, 3, 4. So positive 1 over 4. Ooh, you have a choice here. So remember, if it's going up to the right, it's positive slope. So even if you missed up the going down up, in the end, look at it overall. Is it going up to the right? It should be positive. Down, it's going negative, right? Okay, so which two are the perpendicular ones? Yeah, these two. And so how do we, do you know the symbol for perpendicular? No, double lines are parallel.
Is there a symbol for parallel?
It's kind of like a plus sign. It looks like an upside down T. PQ is perpendicular. Looks like that. Have you seen that before? Perpendicular. Oh, what am I doing? Stop that. Stop that. RS is perpendicular to TU since their slopes are what? Are not just opposite. So if you say opposite, you have to say opposite and reciprocals, or you can just say negative reciprocals. Negative reciprocals of each other. All righty. You guys want to go on to the next one? Okay. Next one says, is quadrilateral BCDE a trapezoid? Okay. Do you know anything about trapezoids?
No.
What makes a trapezoid versus, like, actually, maybe we should discuss what kind of quadrilaterals are actually out there. There's squares, rectangles, rhombuses, parallelograms. Octagon is an 8-sided one. Four-sided. Quadrilaterals are 4-sided. Yeah? Okay, so a trapezoid, all of those that I mentioned, like the rectangles and squares, they have 2 sets of parallel lines. Yes? A trapezoid is the only one that I mentioned that only has 1 set of parallel lines. So, oh, it says right here, a trapezoid has 1 pair of parallel sides. So we need to look at them and find the slope. So we have to do all 4 slopes here. So I'll give you a second to calculate M of EB. That's a bad M. I'll try that again. M of EB. M of BC, that's slope. M of DC. And M of DE. Okay, so I'll give you a second to find all 4 slopes, and then you're going to, obviously by just looking at it, you can tell, well, you have a good guess that EB and DC are the parallel ones, but we're going to prove it using slopes, okay? So I'll give you a second to figure that out. Let's do this. Okay, EB. Up 1 over 2, 1/2, yes? BC, down 1 over 3, so negative 1/3, yes? DC, up 1, 2, 3 over 1, 2, 3, 4, 5, 6, so 3 over 6, which reduces to 1/2. And DE would be up 1, 2, 3 over 1. So then I get 3. Is that right? Did I do anything wrong there? You don't think so? Okay. Hey, that's kind of cool though. What did you notice there? Well, yeah, these are the parallel sides, but I didn't expect this. They're perpendicular, and I guess that would be if you extended them, you'd see that they actually intersect at 90 degrees, right? They threw that in just to see if you're paying attention, I think. Okay, so therefore, we got to answer the question. So the question says, is quadrilateral BCDE a trapezoid? So therefore, BCDE is a trapezoid since it has one pair of parallel sides. EB is parallel to DC. Huh? This is the name of my quadrilateral here, BCDE. Yeah. Because the question actually read, is quadrilateral BCDE a trapezoid? So I got to answer the question. It's kind of like on a test, if I said, you know, Melissa did this question, is she correct? Justify. If you don't actually say if she's correct or not, I can't give you full marks, right? So you got to make sure you're answering the question there. Okay, moving on. Is this a right triangle? Justify using slopes. We're going to find the slope of AB, the slope of CB, and the slope of AC. And then we're going to discuss how would I justify that this is a right triangle? Yeah, it has to have that 90-degree angle, which means the two lines are perpendicular. In grade 9 or grade 8, you learned a way to justify something was a right triangle. Does anybody know how you learned that? It's a theorem. A squared plus B squared equals C squared. And that only works if there's a 90-degree angle in there, right? So you don't know what that length is, however. So you couldn't use Pythagorean theorem. Eventually you'll learn how to figure that out. Okay. I'll give you a second. AB is down 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So negative 2 over 8, which is negative a quarter. Did you get that? Yes? CB, up 1, 2, 3 over 1, 2, 3. So that would be 3 over 3, which is 1.
Why is it negative?
AB is going down to the right. Same with AC, it's going down to the right. It's going to be negative, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So down 5 over 5 is negative 1. Ooh, so which one is the ones that are negative reciprocals? Did you know the only number in the number system that you can reciprocate and it's still the same is 1 and negative 1? Because if you flip negative 1, it's still negative 1, right? And if you reciprocate 1, it's still 1. It's the only number in two numbers, I should say. Okay. In the math, the number systems. Okay. So did we answer the question? Not yet. This is all our justification, but we got to answer, is ABC a right triangle? Therefore, ABC is a right triangle since CB is perpendicular to AC. Done.